scientists practice safe science, safe chemistry. Got to put gloves on for this one. And at the end, I get to call one volunteer. Leave your hands down for right now. I have to set it up first. Another one of the safety arguments I lost. Okay, so this pool oxidizer just happens to be hydrogen peroxide, just like the stuff you have in your bathroom. Only this is about 10 times stronger. This is 30% hydrogen peroxide. The stuff underneath your sink is 3%. So what that means is if you take 100 parts of that hydrogen peroxide, if you were to divide it up into how much of it is water, how much of it is hydrogen peroxide, 3 parts are hydrogen peroxide, 97 parts are water. In this case, 70 parts are water, 30 parts are hydrogen peroxide. So, ta-da. So, that was going to be my next question. Do you guys see how much different the hydrogen peroxide looks than water? Totally different, right?
No.
No.
Looks identical.
Totally.
Okay, all it's got is an extra oxygen crammed onto the end of the molecule. So that's a fail. We didn't make elephant's toothpaste yet, did we? So we went back to the drawing board and thought, you know, toothpaste has bubbles, right? Okay, so the cafeteria had some leftover soap, and so we thought, maybe we can try that. You know, soap doesn't taste good to us, but the elephant, all he eats is peanuts, so maybe he won't be able to tell the difference, and it might be okay. So, you know, let's try to make our elephant's toothpaste by adding a little bit of soap.
Ooh, it's green.
So, still not toothpaste, getting closer maybe like mouthwash, but you know, I still wouldn't try it. Still wouldn't brush my teeth with it, that's for sure. So, when I was about your age, the best that they could come up with in toothpaste was the old white tube Crest. It was a dull green, pasty looking junk. Okay, chalky. Okay, so one of the most exciting things that happened in toothpaste when we were kids is the advent of AIM toothpaste. So as soon as they had those stripes of color in it, we all ran around and cheered in the bathroom and said, "Wow, now we're happily going to brush our teeth." Before that, it was a chore for our parents to get us to brush our teeth.
And then they had color TVs.
So yeah, and then they had color TVs too. You are old, aren't you?
He's not that old.
Yeah.
39, but he ain't that old.
39?
You.
Holy cow. Yeah, I got you.
Oh, he'll
I got you beat. Okay, so we're going to add some color and see if we can come closer to elephant's toothpaste. And the last one here. So a little bit of blue, a little bit of green, a little bit of red. Remember those? They're going to come back up. There's a test at the end.
Ooh, the band looks like
You knew there was a test, right? Along with the math, there's a test.
There's no filter for tests.
The other guys didn't tell you there's a test? Okay. All right, so now is the point that I can call on that volunteer. Yeah, why don't you come on? All right, so grab a pair of glasses. Out of here. Yeah, I'm sorry, I didn't correct the people before. So, all right, so come on up and over here on this side of the table. And what's your name again? Isaiah. Yeah, that's what I thought. Okay, so Isaiah is going to help me out, but we have to get him gloved up for safe science. And we're going to try to see if we can make elephant's toothpaste. So in chemistry, we frequently have to, in order to make a chemical reaction go faster, we do something that's called catalyzation. If we catalyze the chemical reaction, it just goes faster. So we're going to show you the rapid breakdown of hydrogen peroxide by adding a catalyst. And in this case, our catalyst is potassium iodide. Does anybody want to try the chemical formula for potassium iodide? No. What's the? Tell me the chemical formula. No. Chemical formula. Potassium iodide. Okay, we'll talk about it in a second. Okay, so I want you to take as much of that and pour it directly in, dump it in, but hold on to the scoop. You don't want to lose the scoop. And dump it all at once. So that looks more like elephant's toothpaste, doesn't it? No. Okay, remember I told you it was a fictional story? At least I hope I told you that part. Fictional story, it's not real. This isn't real toothpaste. So Isaiah, what I want you to do is, you see all this stuff up here? You see this stuff up here? What does that look like to you? Up here.
Gas.
Gas. What kind of gas?
It's a mountain.
What does that most look like?
Smoke. Cloud.
Looks like steam. Okay. So,
What?
steam. So, this is an exothermic reaction, so it creates a bunch of heat. So, heat mixed with water, hot water, makes steam, right? So, this is actually steam. The oxygen is mixing with the soap, and that's what makes the soap bubbles. Okay? Now, something that I learned in my second semester of chemistry in college will be demonstrated right now. Reach through there and just touch the cylinder and tell me what you feel.
Hot.
Hot. Yeah. Second semester of chemistry, I learned that hot glass looks identical to cold glass. Yeah. So, in fact, this experiment gets burn you hot. Okay, the glass will actually get so hot it will actually cause thermal burns. So there's a whole bunch of heat that's evolved. Okay, actually this experiment is evolving heat, so it's called exothermic. There's another reaction. I don't know, maybe in the work here with PSOs, with if anybody gets injured, a twisted ankle or something, you take the chemical ice packs.
Yep.
When you break that up and shake it together, that's a chemical reaction. There's two chemicals that mix together when you break the inner pack. That's an endothermic reaction. So it's absorbing heat and it gets cold. Okay? So, elephant's toothpaste. That is just the rapid breakdown of hydrogen peroxide.
Why can't we taste it?
Because it's soap bubbles and food coloring and now we never taste anything that's in a chemistry lab, okay? Because we don't know what else is mixed with it. So let's take the gloves off.